episode of FUM0093 machining we are dealing with the rest to do with this dividing head, this Chinese dividing head. What we are going to do, first we make a special nut for the drawbar, and then we are going to bore holes into the adapter plate I just made. So it will be, some lathe work. Unfortunately, I already did the lathe work for this one, but I will show you what I did. And then we are doing some silver soldering, and after that, it will be setting the holes in place and then using the dividing head itself to locate the holes in the adapter plate. That's about what we are going to do today. So the first thing is to present you the special nut. Well, this here is the special nut. So it's just a piece of it's a tube. From this side it's M12 thread, goes about this far, and then we have a recess here, 14 millimeters, okay, and then we have this. This is a cap hex, whatever, Allen screw originally, M10 I believe, and then I'm going to use the cap of that one. This is going to be silver soldered here, and yes, I'm already made some recesses here, so I will place the solder here in advance. I already cleaned up these parts really well, and then I left some room between this part and that, so that there is room for the silver solder to be in. Well, that's next going to set this up and then solder it. Okay, here is what we need. This is the thing I'm going to do now. What is important here is that everything must be absolutely clean, no grease. Grease is poison for silver soldering. And I have these parts, that one and that I already have cleaned up, so that one. I will keep this piece of silver solder in case we need some more. Okay, first one we apply flux, and now you have to remember that flux should be only where you want the silver solder to attach, to wet, nowhere else. So if you put silver solder in this flux in places where you don't want the silver solder to go, you get your silver solder in a place where you don't want it. Quite simply. Oh yeah, this is a little bit difficult. Okay, let's see now. You don't need much of this stuff, but it should be evenly everywhere you need it. Okay, now I just put this cap here. Okay, and then now I wipe off the excess from here. I don't want it to go on this surface. I want to keep it out from there. Hopefully it stays out from there. Sometimes the flux goes there even if I have it. And now what I do, I just place the ring. I already formed this here. Now what I need to do is to warm it up, and I have this very rusty M12 screw, which I put here, just a few turns, so that it supports it. And now we have it there. Okay, next step will be to warm it up. Now I will warm it up with my... This is just an ordinary butane torch. Nothing more. No fancy things here. Well, warming it up. First a little bit gently, so that the fluid in the flux dissipates, evaporates. And when ready, we can put in full power. Sorry about the noise. Let's see now. It should start melting on the top quite soon. This is a thin piece after all. I have to see that the cap also warms up, otherwise it doesn't wet on that one. Well, it's glowing. Oh yeah, there you go. All the way in now. I could add some more here. That's enough. Okay, then let it cool down. What you don't want to do is to drop this into cold water or something while it's glowing, because this will actually break the silver solder. So now we just wait. It has, there is a capillary action which has taken place. Well, it's now going, it's there now. And now we just wait a little bit so it cools down, and after that I'll clean it up and we have a special nut. Here is this thing I made the previous episode. And now we have the special nut. I cleaned it up a little bit. The silver solder went exactly where it was supposed to go, but in addition it wetted this cap a little bit. Well, what can you do? Sometimes it does that. And then let's now try this out. So first this one goes here. And then this is supposed to screw here from the back side. Okay. So actually that one goes here, and then I screw this from the back side here. In, like that. And soon you will understand why this Allen screw is needed. This is just to make it so that I can tighten it, like that. Let's center it somewhere in the center, like that. Okay, now it's there. And this one stays there, but, well, the next thing first of all, now I can because I made this special screw, I can now tilt this all around where it is needed to go. Oh yeah, so that was the reason for that special nut. If you put an ordinary nut there, it is too high, and if you make a nut low enough, you cannot use any wrench on that one, but this one goes. And now I need to place this, I need to bore the holes into this this adapter. Yeah. So first I will indicate it upright, and after that I will find the center for that one with the milling machine, and well, I will yeah, that's one way to go. I don't know how to locate these. Well, maybe I will measure it. What's the radius of these holes? After that, when I know the radius, then I can just turn it 90 degrees, bore a hole, 90 degrees, bore a hole, 90 degrees, bore a hole, and so on. That should be okay. Yeah, okay. I'll set up this thing now. I centered it with a very unorthodox way. Well, it's center enough. I assume it's 0.1 millimeters in the center, but these are a little bit sloppy, so therefore you can actually bump it into place. And yeah, now the next thing I already figured out. Here's a plan how to move around, and then 50 kilometers, no, okay, let it be. I'll cut this off, or maybe not. It's a very nice, I will put it somewhere else. Okay, so I need to know, I now know the places where they go, but I need to know the depth of the holes. I don't want to bore through this material. Just there as near as possible. So I measured this one and it says 19.5 millimeters. And when I look with this one here, is it enough? Well, it's more than enough. Okay, so we will be drilling down, not boring, drilling. Wait a minute. We will be drilling down, well, let's say 17 millimeters. Is that enough? Yeah. With the bottoming tap, you should be there. 17 millimeters. And I have checked from this book that the drilling size for M8 tap bolt is actually 6.466 millimeters. So I have here the minor diameter. So I have 6.5 millimeters drill here. This we don't need anymore. It's just on the way. And now let's see. I will first drill the holes, and then I will use, well, my nice tapping equipment in the drill press to make those holes, to tap those. Okay, so, well, what can I say? Let's go. I will do this, the rest of the 3 holes off the camera. 4 holes done. And now I have a chamfering tool here. I will chamfer these holes, and now this is the great opportunity to check whether these holes are in correct places. This. And now the very important backside. Ah, no penetration. Well, now I will set up the drilling, tapping equipment and tap those 4. Tapmatic. This is the first time I really use this one in real life. I have now adjusted the speed almost slowest possible. Well, it is the slowest gear, but I have this is in normal speed. I could slow it down even more. And now there is this torque selector. I have set it well somewhere around 3. It shouldn't break this tap. This is M8. But well, who knows? Never done this before. This is, by the way, not a bottoming tap. This is a plug tap. So let's see now then. What kind of, if I break the tap in the hole, so then I'm basically screwed. Yeah. Well. Why? It didn't break the tap. So, too much torque, I would say. Okay, it didn't break the tap. Ah, okay. Now, it's too little. It's too little. So I need to increase the torque. Just a little, like that. Yeah. This has a tendency to... Well, this is actually quite okay once you learn to use this. But yes, this is really... It doesn't hold it. Bye! Last thread. Well, I believe that one went as it should. Okay, all 4 holes are now tapped. I have now drilled the holes, and hopefully they are in the correct place. Well, let's try it out. I had to clean up these bolts that came with this chuck. This is also a Chinese. Okay, that's the first one. Yeah. Okay, next. And also this seems to have sharp corners. Size. That's not good. I get damaged with this type of things, which are not well bored. I need to do something for that as well. So now we are attached to this. Nothing is bubbling here. And now we can put it here. Wow. So it's there. Oh, I forgot one thing. Oh, my nice drawbar. Do I need it? Yes, I need it. Nice choice, isn't it? You can put it here and take it away. So I chose this this thread so that you can put it from here. Well, it was not planned, but that's an accident. I mean, just got lucky. I had no thought about that thing. So, one nice thing about this asymmetric, so it's not round, you can hammer it in. And then you just screw this one in from here. Well, no, now it stopped. So, you can screw it in like this, then you can tighten it, and it's sitting there, going nowhere, I believe. Well, oh yeah, I need to indicate this one maybe. Yeah, it's, well, it's a 4-jaw chuck, so it means that if it is straight, no whiplash, so then it shouldn't matter. I can always use the 4 jaws to center the things, and actually I must. And therefore my choice. So, well, okay. I will show you one thing that I'm a little bit wondering here, and it's starting to be a dividing head. Here we have this piece of brass, which is supposed to be, so it points to the degrees here. Okay, when I put it into place like this, where it should be, well, the degrees are unreadable after this. So what went in their heads when they did this? Well, I need to adjust this one so that I can read the degrees really. Okay, let's do some bending. Well, now it is readable. I index it with the, so it's exactly on 0 now. So, okay, that's done. It's tight, doesn't move, it's readable. Okay. Now, well, just this shows out that they have in this they didn't do nothing that would be unnecessary. So I mean that they didn't do this thing correctly. And furthermore, I have a suspicion that this oil hole, I have to plug it out at some point. I believe it's blocked, so I cannot get oil into there. It might be blocked. Well, who knows? Let's see. That's one. After all, I don't know whether this needs oil. There is grease on the backside, grease on the here. This is the only thing that probably needs oil, but there is a hole for that one. Just put a few drops every now and then, and that's it. And the worm is grease. So probably no oil needed. So this is actually a decoration. Okay. Next thing will be this flimsy thing. These components, first of all, this seems like brass, right? But it's not. It's cast zinc. Oh yeah. This is the, no. It might be. Actually, it's hammered somehow. I don't know why. There is a marking. I didn't hammer this one. Okay. So, and then for some reason these Chinese things favor to use a lot of different tools. So, in order to change this wheel, you need a Phillips screwdriver for these three. Then you need one type of Allen wrench for that one. Furthermore, you will need yet another one for this one. So, three tools. All of them could have been done for one size, if needed. So, yeah. That's one thing I have noticed. It's the same thing with my lathe. There you need a bunch of tools to change gears. I don't know why, but so it is. Okay, enough whining. This is now ready to use. My first task will be this one. I need a scale here. And when I get these gear cutters, there will be a gear as well for automatic feed, because I need that one in this lathe. This lathe is too fast, the feeds are too fast, so I need that one. So, but the scale now, I can do that from aluminium, and let's see how that goes. Now the lathe lead screw hand wheel dial in working. So the lead screw is 3 millimeters per revolution. Okay, so I need to do here division. First of all in 3, and then in 6 half millimeters, and then 30 as 1/10 of a millimeter, and then the final will be like 2/100 of a millimeter per line here. 100 would be too close and would look bad. How I do this is that when I make this disc in the lathe from a flat aluminum plate, just cut a quadratic piece which I then made round. And now I have dialed this in here. I have a 4-jaw chuck here. Nice, easy to dial. So I can put it exactly where I want, and that's nice. And then this is beveled. There are 3 bevels here. One is 60 degrees, one is 30 degrees, and one is 0. So now when I use this slitting saw here, so I only cut 1 bevel. So therefore I get the graduations in different bevels. And I guess that's quite easy way to do this, because I don't want to start graving here. That sounds bad in my ears, because this machine is not very good in graving, I believe. And hand graving this, no. You could do it, but no. So now I have selected, because now there is this disc with 15 holes. So this means that the entire revolution yields 40 times 15, which is actually 600 holes for a revolution. So now I'm doing the 1/10 of a millimeter, and this one is now 20 holes. So when I move to the next thing, release the brake, and then 1 turn plus 5 holes. 15 plus 5, that's my mathematics. And then let's just make the next graduation. It's really easy. There you are. That's the next graduation. Then next, brake. And this is a little bit bad, you have to peek under there. Yeah. And it's really easy to lose sync here. And it's always exciting whether the last hole is in place or not. There you go. would like to show you something about this milling machine, which I really like. So, I have finished my horizontal milling. Well, very light horizontal milling, but nevertheless. Now I would like to convert it back to vertical milling. Well, normally you would need a dial indicator or somehow tram it and whatever. In this case, this is the only tool I need. So first I release the locks and then let's push out the head like that, about there, maybe, yeah, okay, and then rotate it to a suitable position like this, index it. You can also read here 90, and now it's trammed already. And now this one then, this is also easy. So you, well, it's not easy to loosen the bolts, but okay. Now when these 4 bolts are loose, here at the back side, which you don't see, that's bad, so there is a indexing mechanism. Now I rotate it, and when I found it's around there, there you are. There is a pin and hose which this ejects out, and then it's also trammed. There you are. And yeah. So, and now I can also about there, and then I just lock it. There you are. And now the precision here. This level there is about 20 centimeters, 2/100ths of a millimeter difference. And this direction, it's even less, it's something like 1/100th of a millimeter. So if you are using small end mills, so it doesn't matter. You cannot, your, well, setups might be less accurate than that. So, how much did it take for me? 2 minutes maximum. No tramming, just put the indexing in place and there you go. And furthermore, this rotation, which one was the rotation? I always forget. Oh, so this has indexes every 15 degrees. So you can easily go to whatever position you like, and also we have a graduation here, so you know about where you are here. And this is and yeah, only tool you need. Would this be a Chinese, I would at least need 6 tools to make this to happen, plus the dial indicator, and maybe also take some rice noodles in between to make it happen. Well, that was a bad joke. Okay. Well, here I'm here. Now I sand the burr. It has quite noticeable burr in it. So I use just a sanding block, and well, I have covered my waste because this one is going to emit some, well, okay. Let's see how it looks. and I do that. Oh, it looks alright. Okay. There is a tool to take it away. Well, this was really flimsy setup, but well, now it's a lot better. All I need to do is to clean it up, I believe. And now, after cleaning up, I need to chuck it, and after that I need to bore this hole a lot bigger. Well, I had some fun indicating this one. I got it in place in 1/100ths of a millimeter, but yeah, these are rubber. So it was sort of rubberish. And well, I indicated on these surfaces, and that was actually very well, not very easy task to do. Well, the next thing is to find my biggest drill, and for the first drill this hole quite a lot bigger. This is my biggest drill for Morse 2, and it is 22 millimeters. Well, and I'm not sure whether it is sharp or not. It might not be sharp. Well, this is aluminium, so no worries. Let's see the speed. Well, with aluminium one can hopefully my rubber thing holds. Yeah, okay, okay. Oh yeah. Huh. Hand operation works better than in the lathe. Oh yeah, it's really... Okay. Let's put it into place. Let's see now how this comes apart. Oh, there is some long screw. No, it's not long. And this should come out like that. And now we can actually put it there. Fingers crossed. A little bit tight. That's actually good. Okay, that's the 0.1 millimeter. But I will make, let's see how much it wobbles. No, it's backwards. Should be this way. Doesn't wobble at all. Very good. And now I need to, not in this video, and I probably will do that all alone, a friction mechanism so that it you can still like turn it a little bit. We have this precision knurling here, so we can turn it easily, and then maybe stamp some fancy numbers here. Well, and then there will be another thing here. It will be somewhere around here. Same material. And then we have here a gear. There will be a drive system. I will attach it to this here, which will then I can feed slowly or fast or anything in between. Well, it's not yet ready to be used, but we know it fits there actually quite good. So we can put this back. This also needs 2 tools. No, 1. There you are. Yeah. Okay. By the way, this isn't Chinese. If you haven't been following my video, so there is one video about this thing. The original was really sloppy. That's the correct word. And here we have one thing that is that's the original dial. Well, there is also a mathematical error here. Well, 0.4 thousandths is not 0.11 millimeter. No, it's not. It's near, but it's not. So if you use that, you might end up having strange results. And then, yeah, this is the new one. Well, I don't know, maybe I should put some black paint there and then wipe the excess off so it stays in the grooves. Maybe. Yeah, let's see. Okay. Well, this was now all about this dividing head. The construction kit of a dividing head. So, is it worth the price? Well, you definitely need to do something to make it really good. You need to change some of the fasteners because they are, in my opinion, wrong type, and then you need to clean it up. To clean it up, you really need to dismantle it. So you cannot just start using it right away from the package. That's impossible. So I would say, well, after this job, it is worth the price. But if you don't like cleaning up things, if you don't like to make them less Chinese, make them a little bit more usable, then this one is not for you. But if you really like making things a little bit better, not super, but a little bit better, and so on, so then, okay, it's a very good construction kit. Not very expensive, and actually that dial was I intentionally made it also so that it shows whether this thing repeats or not. It repeats, and that's a good news. Well, okay. In the next episode of FUM0093 machining, well, who knows what we will be doing. Till then, see you!